Hello, we're going to take a little bit of a different form here. We're going to look at an example here. You'll have to pardon my handwriting if it's not the best as we go along. But we're going to take a look at another Newton's second law of forces example. In this one, we got a box of magical orbs that have a mass of 84.5 kilograms. They're being pulled at a constant velocity by a force of 482 newtons. That's at an angle of 18.2 degrees above the horizontal. We want to figure out what is the coefficient of kinetic friction. So one thing we want to recognize that's very useful is that we're going at a constant velocity. So just as a reminder, when we look at things at a constant velocity, that's telling us that our acceleration is 0 meters per second squared, and that all of our F net, our forces, are going to be equal to 0 newtons as well. They're all going to cancel out. So when we go and look at our free body diagram here, we're going to get all of our forces to cancel out. So I'm going to draw a free body diagram here. I got my box of magical orbs. What do we know here? We've got a force of gravity, of course, acting down on our object. We have our force normal here going up from the floor, holding up our box of magic orbs so that they don't fall off. We've got a force of 482 newtons. It's at an angle of 18.2 degrees above the horizontal. So usually we draw a line straight out here, but this time we're going to draw our line going just up a little bit. So this one's at 482 newtons, and that's at an angle here, 18.2 degrees. What else is going on? We should have a coefficient of kinetic friction, so that means we must have a force of friction. If the box is sliding along a floor here, that force of friction would just be parallel to the floor going off this way. Okay, so what I'm going to want to do here is take that 482 newtons. It's going at an angle. It's not going in the same direction as all of our other ones. So I'm going to break that up and make a right triangle out of it, so that I've got my two components, one going up and one going down there. And we can do a little bit of some trig stuff. Like if I wanted to find this part here, let's call it X, and this part Y. I've got my angle. The 482 is the hypotenuse. So if I want to find these two components, this is the adjacent side. So adjacent and hypotenuse, we're dealing with cosine. So I'll be doing the cosine of our 18.2 degrees. That's not very clear there. 18.2, obviously. And that's going to be equal to that side we don't know over our hypotenuse, 482. If I multiply the 482 over there, cosine of 18.2 degrees, times 482, that would give me that X is 458 newtons. I could do the same idea with Y. Now we're dealing with the opposite side from that 18.2 degrees. And we still got our hypotenuse. So it'd be the sine of this 18.2. That's a little bit better written. Equals Y over 482. And that's going to be that Y then. If I multiply 482 over here, 482 times sine of 18.2, that would give us 151 newtons. So we've got these two parts. Let me write it onto here. 458 newtons and 151 newtons. Maybe I can erase this Y part. We don't necessarily need that anymore. Oh no, I lost my line. All right. So what do we got here? I'll move my box up here. So we know it's going at a constant velocity and that our forces are going to cancel out. So I'm going to switch back to a nice black pen here. So what I know, if I'm looking at my picture here, is that this normal force and force of gravity, which we're used to seeing cancel out, there's another culprit involved in my vertical part. I got the force of gravity going down, and then there's a normal force going up, but there's also this 151 newtons. So if I want to deal with that vertical stuff, That vertical stuff I'm going to have going down the force of gravity, and that's going to equal going up. There's the normal force and the 151 newtons. I've got those two going on. So I've got those both involved. If I go a little bit over here for my horizontal stuff, going the other way. If I look that way, there's a force of friction going to the left here. The only thing going to the right is that 458 newtons. That's a little bit easier on this side. Ooh. So I've got that force of friction, and that's going to equal my 458 newtons. Those are the only two horizontal forces in my free body diagram. One's the left, one's to the right. It's going at a constant velocity, so those two are going to balance each other out. So when I look at the force of friction, the force of friction is, just looking back from what we learned previously, our force of friction is going to be mu k times the normal force. So I'm going to replace force of friction here. Force of friction is the same as my mu k times the normal force. And we know that's force of friction is 458 newtons. So we need to figure out what this normal force is. So I'm looking back over here at the normal force from my vertical stuff. So my force of gravity is going to be the force of my mass times 9.81. If I look back at the question, you have it written down, the mass is 84.5 kilograms times 9.81. That's going to equal that normal force plus this 151. So I've got everything in here except for that normal force. If I subtract 151 and bring that over here, my normal force then, if I do 84.5 times 9.8 and I subtract 151, I find that the normal force should give us about 678 newtons. So what we're going to do then is just plug that in over to here. And we're almost done. So we're going to figure out what our mu k is. I got mu k, don't know, but the normal force is 678. And that equals our force of friction, which is 458. We're going to divide both sides by 678. And our coefficient of friction, when we divide those two, we should have 3 sig figs. We'd get a final answer of 0.676. And that matches with our mu k. Our coefficients should always be between 0 and 1. So we got 0.76. I don't know what just happened there, but that would be our answer for that one. So it is a little bit tricky, but when you look at it, we took our forces, we split up that one that was at an angle, and then we said whatever the vertical stuff is, if it's a constant velocity, we set those vertical stuff, the downward force equaled the two ones that were going up. And the same idea for our horizontal force, the one that was going to the left here, and it was equal to the one going to the right here. We just broke it apart into vertical and horizontal would be a big first step there. And so that was an example there with that force at an angle. I hope you enjoyed it. It was pretty fun. So we'll probably go on to another example, similar, but of course different.